Previously, we learned that force causes changes in motion, and any attempt of change in motion is being resisted by inertia. Inertia is measured by the object's mass. Now, you are ready to quantify the effect of force and mass to acceleration. Let's analyze the situation. Two wooden carts having the same mass of 2 kilograms are lying on a frictionless horizontal floor. The first cart is pushed with a force of 2 newtons to the right. The second cart is pushed with a force of 4 newtons to the right. Which of the two carts obtains greater acceleration? Because both forces are directed to the right, both carts will accelerate in the direction of the force. The acceleration of cart 1 is 1 meter per second squared, while the acceleration of cart 2 is 2 meters per second squared. Acceleration of cart 2 is 2 times greater than cart 1. Now let's introduce a third cart in the situation. Cart 3 has a mass of 2 kilograms, similar to the masses of cart 1 and cart 2. However, it is exerted with a force of 8 newtons to the right. Compare the effect of this force to the first two carts. Since the force exerted on cart 3 is 4 times larger than the force exerted to cart 1, then it is 4 times farther in displacement after 1 second. Its acceleration is also 4 times greater than that of the acceleration of cart 1. As observed, the greater is the force applied, the greater is the acceleration. Acceleration is directly proportional to net force. Now let's investigate the effect of mass to acceleration. Two wooden carts lying on a frictionless horizontal floor are pushed with equal amounts of forces of 10 newtons to the right. The first cart has a mass of 5 kilograms, while the second cart has a mass of 10 kilograms. Which of the two carts will have greater acceleration? Since mass of cart B is greater than mass of cart A, the inertia of cart B is greater than that of cart A. Therefore, cart B has greater capacity to resist acceleration. The acceleration of A is therefore greater than the acceleration of B. Acceleration is inversely proportional to mass. The smaller the mass is, the greater is the acceleration. Combining the effects of force and mass to acceleration, we could now state the second law of motion, or the law of acceleration. The law of acceleration states that acceleration is directly proportional to force but inversely proportional to mass. Problem number 1. A 5 kilogram object is pushed along a frictionless floor with a force of 3 newtons. What is the acceleration of the object? The mass of the object is 5 kilograms. Force is 3 newtons and we are looking for acceleration. The formula is A equals F over m. Acceleration equals 3 newtons over 5 kilograms. Acceleration now is 0.6 meters per second squared. Problem number 2. How much force is needed to cause a 2 kilogram object an acceleration of 6 meters per second squared? The force is unknown, while mass is 2 kilograms and the acceleration is 6 meters per second squared. The formula is F equals ma. Force equals 2 kilograms times 6 meters per second squared. Force equals 12 kilograms meters per second squared, which is the same as 12 newtons. Problem number 3. What is the mass of an object accelerated at 4 meters per second squared by a force of 20 newtons? The mass of the object is unknown, while its acceleration is 4 meters per second squared, and the force applied causing that acceleration is 2 newtons. From the formula F equals ma, m equals F over a. Mass now is 20 newtons over 4 meters per second squared, which is equivalent to 5 newtons per meters per second squared, where newtons is equivalent to kilograms meters per second squared. We could now cancel meters together and seconds together. The mass now of the object is equivalent to 5 kilograms. I hope that this material had helped you understand the lesson on the law of acceleration. Previously, we learned that